Just kind of finishes up the solving of fractions. Solving of equations. So solving by looking inside, Derek and Donovan were trying to solve the equation 4 to the fourth equals 16 to the x. Derek had an idea. He said, I know 16, isn't 16 equal to 4 squared? Yeah, so what? Said Donovan. That means that we can rewrite the equation to look like the following. 4 to the fourth equals 4 to the 2x. This is much easier to solve. Derek replied, yes, said Donovan, that makes sense. Isn't there another way too? Since 4 is the same as 2 to the fourth and 16 is the same as 2 to the fourth, we can rewrite it as 2 to the second times 2 to the fourth to the x. What were they thinking? Well, both methods worked. Use both methods to solve 4 to the fourth. So essentially what they're saying is the problem with this is comparing the base to the exponents. There's my kid making a smoothie. If you can hear that in the blender. I apologize. So long story short, the base is not the same, so it's difficult to compare the exponents. However, if we make the bases the same, whether we make that base 4 or that base 2, then we can just compare the exponents. So if we rewrite 4 to the fourth equals 16 to the x, again, we're just saying I'm going to use that base of 4. And over here, how do I rewrite 16 with the base of 4? Well, it's just 4 squared, right? Isn't that 16? So I haven't really changed anything in this equation. But now I have the bases. So it's 4 to the fourth equals 4 to the 2x. And now I can just say, oh, look, well, 4 should equal 2x because if the bases are the same, the exponent should be the same. So 4 equals 2x. By the way, you're not allowed to just drop bases like this. You will learn something your junior year or in integrated 3 called logarithms, and that will actually help you solve these kinds of equations. So I'm a little bit annoyed by this, but the long story short is 4 to the fourth should equal 16 to the second. So let's see if that's true. Does 4 to the fourth equal 16 to the second? They both equal 256, so x equaling 2 makes sense. And then the other thing is they said, well, all right, well, we start with this equation 4 to the fourth. We didn't have to use a base of 4. By the way, it's usually easier to go down in base, not up in base. You wouldn't want to turn 4 into a 16. That's kind of a pain in the butt. You can do it with fractional exponents, but most of you don't have any idea how to do fractional exponents yet. You won't learn that till sophomore year or integrated 2. So I would say go down in base. It's a little bit easier. But what if we said, oh, I'll rewrite 4 as 2 squared, because isn't 2 squared equals 4 to the fourth power? And then I'll rewrite 16 as 2 to the fourth power. I'm sorry, 2 times 2 is 4, times 2 is 8, times 2 again is 16. So it would look like this. I'll use my rule of exponents to multiply there. I get 2 to the 8th equals 2 to the 4x. And again, now we just completely ignore real math and say, oh, I'm going to drop these bases and just worry about the exponents. And again, you can see you get that x equals 2 either way. So that's what they're looking at with these kinds of problems. It's not exactly correct math, but it is an interesting way of looking inside and just trying to look at a problem and think of a easier way to solve it. So let's try a couple of these examples. And again, I would strongly encourage you to try some of these on your own before we do them. But hey, look, the bases are the same here. So since the bases are already the same, I don't really need to do much. I'm just going to say that the exponents have to be the same. So I'll say x plus 3 must be equal to 2x. Subtract x from each side, and 3 equals x. And again, that if I said that x equals 3, that would be like saying 2 to the 3 plus 3 is 6 is equal to 2 times 3, which is 6, which is obviously true, right? All right, if I go here, again, 3 to the fifth equals 9 to the 2x. Well, I'm going to make the base 3. This already has a base of 3, but this I'm going to say, how do I write 9 as a base 3? Well, it's just 3 squared, right? 3 squared is 9. So it'll look like this. I'll use my rules of exponents. I get 3 to the fifth equals 3 to the 4x. So I'll drop my bases again incorrectly. I'm ignoring that logs are a thing and dividing by 4, and I get 1.25 equals x. So if I go here, x equals 1.25. So we'll go to the calculator and we'll ask ourselves, is 3 to the fifth the same as 9 to the 1.25 times 2, so that's going to be to the 2.5, right? So we'll grab our calculator. 3 to the 5th equals 243, and 9 to the 2.5th hopefully equals 243, and it does, so we feel confident that x equals 1.25 here. All right, moving along, kind of clearing up some room here. Excuse me. Here we have 3 to the 2x plus 1 is equal 3 to the third. Well, I don't need to do anything with bases. I'll just say that 2x plus 1 equals 3. Subtract 1, I get 2x equals 2, so x equals 1. So I have the equation x equals 1, and if I plug a 1 in, 2 plus 1 is 3, so 3 to the third, of course, equals 3 to the third. So C was a really easy problem. And then finally, the last one, I don't know if this is the most difficult. If you're getting the hang of this, it's probably pretty easy now. If not, then that's fine. We'll go through it. But how do I write 8 as a base 2? Well, 2 times 2 is 4 times 2 is 8. So this will be 2 to the third to the 70th equals 2 to the x. And again, I want to make sure I didn't change anything. I just rewrote 8 in terms of 2. So using my rule of exponents, I will say that x equals 210. So the question is, does 8 to the 70th power, I'll just underline it, 8 to the 70th power is probably a giant number, should equal 2 to the 210th power. And again, I'm just ignoring, this is exponential scientific notation, I'm sorry, and that just means that you move the decimal 63. So it's a 64-digit number, which is a gigantic number, but I'm hoping this will be the same, and it is. So you can see x does equal 210 there. All right, so all three methods. So essentially what it's saying is go ahead and solve A through G using whichever method makes the most sense to you. This one I'll rewrite. So I'm going to get 12x squared, right? The left side is 12x squared is equal to, on the right side, I will use an area model, 4x plus 8 and 3x minus 3, 12x squared minus 12x, 24x minus 24. I get 12x squared plus 12x minus 24. I'll subtract 12x squared from each side. I will add 24 to both sides. I will get 24 is equal to 12x divided by 12, so x equals 2. So that's my answer to that one. A little bit of fraction busting, so I'm excited about problem B. So problem B, x over 3 minus x over 9 equals 6. Again, I'll choose 9 because 3 goes into 9 and 9 goes into 9. So here I'm going to cancel. I get 3x minus x is equal to 54. So 2x equals 54. That's a 4. So x equals 27. So x equals 27 here. On this one, we're using our kind of weird stuff that we just talked about. So we will mess with the bases. And again, I'm just going to rewrite 36 as 6 squared, right? That equals 36. So using rules of exponent, x plus 9 is equal to 6 to the 2x. Now I'll just ignore my bases and say x plus 9 equals 2x. Again, that's not real math. You're going to learn logs at some point. And x equals 9. Good. A little bit more fraction busting. I love it. So we're going to go with fraction busting here. 4 over 9 plus 1 over a equals 2 over 3. So 3 and 9 both go into 9, but then I have that a to get rid of. So I'll just multiply everything by 9a and do it all in one piece. The 9's cancel. I get 4a. The a's cancel, plus 9. The 3's cancel, so I'm going to get 6a. Obviously 3a times 2 is 6a. I'll subtract 4a from both sides. 9 equals 2a, so a will equal 4.5. On this one, a couple different ways we can do this one, really. The way I would probably do it and the way that I see it the most quickly is, how do I get rid of a square root? I get rid of a square root with the square. So I'm going to get x plus 3 equals 36, so x will equal, obviously, 33. But I suspect what the book wants us to do is look inside and say, oh, look, the square root of 36 equals 6. So how do I get this to be 36 inside? Well, if x equals 33, and that's really not a bad way to look at it. So probably easier and faster than the way that I did it, but that was not the way I saw it initially. This one, I'll multiply everything by 10, right? So I'll get 12m minus 2 is equal to 38 plus 10m. So I just rewrote by multiplying by 10. I'll add 2 to both sides. I'll subtract 10m from both sides. I was going straight to the answer there. I get 2m equals 40, so m is equal to 20. And then finally, I think the easiest way, probably what they're looking at again on this, is looking inside. So hey, look, 3 squared equals 9. Although this actually has 2 answers here, so you got to be careful. So big kid math, I hope we know that 3 squared equals 9, but I also hope we know that negative 3 squared is equal to 9. So the parentheses could equal 3, which means that x would equal negative 9, right? Negative 9. Negative 9 plus 12 is 3. 3 squared is 9. Or x could equal negative 15, because negative 15 plus 12 is negative 3, and negative 3 times negative 3 is also positive 9. So we get our 2 answers here. X equals negative 9 or x equals negative 15. By the way, if you wanted to see this one, I think probably a nice way to solve this would be square root both sides. And the square root of 9 is actually plus or minus 3. Again, 3 times 3 is 9, and negative 3 times negative 3 is 9. So when I subtract 12 from each side, I get x equals negative 12 plus or minus 3. Again, that means negative 12 plus 3, which is negative 9, or negative 12 minus 3, which is negative 15. I don't necessarily expect you guys to know this yet, but this is, again, something that you'll probably be seeing in integrated 2 and in integrated 3. I'm going to pause here and I didn't check any of my answers for brevity's sake, so let me check my answers, see if I made any mistakes. These were all correct, which makes me happy. Are there any solutions to the equations in the previous problems that are not allowed? Again, we're looking to divide by 0. We're not dividing by 0. There's no x on bottom. I guess here a couldn't equal 0. So yeah, here a couldn't equal 0. Right? We're not allowed to divide by 0. Here, I mean, arguably, we came up with the positive, so I guess we're fine on that one. So yeah, I would just say here a couldn't equal 0. They're not saying that as an answer. Oh yeah, a couldn't equal 0. All right, so that's the only one. On this one, they're saying part E, you're saying it couldn't be negative. And again, I don't do a good job of recognizing those ones, that this couldn't be negative, because there are imaginary numbers that you're going to learn about next year, and so I guess I forget sometimes that you guys don't know those yet. So this couldn't be negative, and this couldn't be 0. All right, that wraps up chapter 3.